So hello everyone and welcome back, and after being absent for a while I'm now coming back with another video, and today I'm back on the Surface Pro because today I'm gonna draw some stuff. And so this is the video that I've been talking about for a while, which is, well, how Capmods work and how to do them. And I'm first gonna go over how they work in theory, and then also what you're gonna see in practice. If you just wanna know how to do them, there will be a timestamp in the description. So, in theory, so why are we doing cap mods? So the first thing you gotta understand is that a capacitor, or short cap, is basically a reservoir, and I really like to say, instead of power, I like to use water as an example. And what a capacitor basically is like a rain reservoir. So you wanna turn on the sprinkler in the garden, and you have like a water reservoir from when it rains. There's water in there, and you can use that water for your sprinkler. And if that reservoir runs out, you can still use your normal tap water, but it takes longer. You have to set everything up first, and it's just a little bit more inconvenient. It still works, and basically that is what a capacitor is for a graphics card or a motherboard, basically any electronics. It is basically a small reservoir that, instead of water, holds like charge or power. And if your GPU, so your GPU on the other side of this right here, suddenly needs a lot of power, or more power than in idle, if your GPU goes on the load and now needs a lot of power, it will empty these capacitors first before it starts pulling more power through your cables and your power supply, your VRM and all the other stuff. And the reason why you want more capacity from your capacitors is this power is incredibly easy to pull. The GPU has no problem pulling the power from the capacitors. There is a problem though if it pulls it from somewhere else, and that problem is, well, your VRM goes on the load, and your power source, your power supply, or your VRM is further away from the GPU than your capacitors, and there is resistance and there is a lot of other stuff. And the result basically is your voltage will drop a little bit. And if your voltage drops a little bit, well, that's bad, because your GPU now gets less voltage. And if you're running a very, very aggressive overclock that needs a steady voltage, it will crash if the voltage goes down. And that's exactly where your capacitors come in. The more capacitors you have, the more capacity you have, the longer the GPU can use that reservoir, and the longer you will prevent a voltage drop. And yeah, that's basically what we do with Capmodding. So yeah, GPU can go on the load for longer without having the voltage drop. And that's a very, very rough version, a very cut down version of the theory of a cap mod. So you want to prevent that your voltage goes down. You want to keep a steady voltage for the GPU, and you give it this reservoir, this capacitance, to pull the power from. So now in practice, what you see is, well, exactly that. You see that you have less of a voltage drop if the GPU goes on the load. So depending on how many caps you use and which caps you use, which we're gonna get to in the how to do it section, you're gonna see a different amount of less voltage drop. Sometimes it can be a lot if your GPU has very few caps, very bad caps. If it's a really cheap PCB, the PCB I have right in front of you is actually one of the better ones. So this is the 560 Ti, if you don't recognize it. This one here is the 460 SE. This is a very cheap PCB, very bad one actually, from the VRM, but the capacitor is actually not that bad. And this one is kinda a similar thing. The VRM is not that strong, but the capacitors it has is actually okay. yeah, and you can see I Capmodded all 3 of these, and on all 3 of these I saw an increase in stable overclocks from the Capmods. And sadly I do not have access to an oscilloscope at the moment, so I can't tell you how many millivolts less I now have in voltage drop, but I can tell you that this right here, so here we are, this is the GTX 670. Before the Capmod it ran a core clock of 1252 megahertz, if I can remember correctly. Now after the Capmod it can sustain 1280 megahertz. So that's a nice increase. Actually, I think it was not 1252, it was 1267. 1252 was the 780 Ti before, like with the stock BIOS. Yeah, so you see a couple megahertz. It should be 1 boost step for Kepler. Kepler has 13 megahertz boost steps, if I remember correctly. Yeah, that's 13 megahertz, so 1 boost step. Like Kepler has pretty large boost steps actually. Maxwell has 2 megahertz boost steps at least. Yeah, the 980 Ti and the 750, which is also Maxwell actually, they step in 2 megahertz increments, whereas Kepler does 13, Pascal does 12.5, and then Turing does 15. So yeah, 15 megahertz is actually a lot if you're really on the edge. And yeah, so from Capmodding this card, basically you see this increase. This right here, the GTX 460, I said that in the video about the card. This one picked up a lot. So stock, it did 800 megahertz on the core. With the Capmod it can now do 950 megahertz. So even though the capacitors are pretty decent, like these are Nichicon FP caps, which are the same ones that I attached, just not to this card, the overall capacitance of them was not actually that great, and they were the caps, actually you can see the legs right here. So these are at the edge of the PCB, and that is not, I mean, that's what you do, but those caps do not that much as these caps right here, and I'm gonna get to that in the practice section. So yeah, this card picked up 150 megahertz if I remember correctly, and yeah, so that's a lot. And this is a reference PCB, so the VRM, the capacitor layout, is stock. And yeah, so NVIDIA reference PCBs up until the 1080 Ti were really crappy actually. So these are the sort of cards where you see the most increase. And then right here, the 560 Ti. For this I actually don't remember. Before the Capmod, I'm actually not that sure how much this picked up. I think yeah, so it ran above 1 gigahertz before the Capmod. I think it was like 1025 to 1040 something. Now after the Capmod it can run 1050 stable, and it will run 1.1 gigahertz for short, but not for long, because heat becomes a massive issue at that point. And because of a different issue with the card, I can't run that many. I can't run a great cooler with that card because of an issue that I explained in the video about the card itself. I thought I solved it, but it came back. So yeah. So on this, the increase was not that great, even though it's still Fermi. Both of these cards are Fermi, and this picked up a lot, but this not so much. Because this is a not a reference PCB, this is a custom PCB from MSI with a rather powerful VRM and also a lot of capacitors. You can see the legs right here, there are a lot of these capacitors on this card. And so me putting on even more, I mean, yeah, it helped, but it didn't help that much because it already had a lot of capacitance and also higher quality capacitors. So yeah. So higher quality capacitors, what do I mean by that? Well, that pretty much brings us to the how you do a cap mod, because that's actually an important thing about how you do these cap mods. So how you do them is basically you get capacitors that you want, and the capacitors that you want they depend on where you want to put them on. So you see I have these silver capacitors right here, and then I have these black ones right here. These are two different kinds of capacitors, well, not actually different kinds, just different SKUs. So the silver ones are 4 volt Nichicon FP series caps. These are 561 microfarads, and yeah, they have so Nichicon FP is a low ESR spec. So low ESR. ESR stands for equivalent series resistance, and then there's also ESL, which is equivalent series inductance. And both of these things are bad. You don't want them. You want as little of them as possible. And so basically what they are is every electrical component in reality has an own resistance and an inductance, and that's, well, the resistance and the inductance of those capacitors. And the smaller the resistance and the inductance is, the better they will work, because, well, if there's a lot of resistance, you won't have that much power going through there, and you're gonna have a ton of voltage drop again because, well, there's high resistance. With inductance, it's about the same thing. I actually haven't read that much into that, so I don't want to make any claims. It's just you also want as little of that as possible. And yeah, so same goes for these black capacitors right here, but these are 16 volt 470 microfarad capacitors, also low ESR. At least they were marked as low ESR. I actually don't know what they are. I think the Nichicons are like 5 to 7 milliohms, and then for the 16 volt ones, I don't know actually. Yeah, so you wanna, if you buy your capacitors, you wanna keep an eye out for low ESR, low ESL. And one way how you can limit those even further is by making the legs as short as possible. So you can see there's not that much of the capacitor's legs left as compared to this one, where a lot of the legs are still left. And yeah, so you don't want to do this, because the longer the leg is, the more resistance you will have, and also the more inductance you will have. So by making the legs as short as possible, you can still reduce your ESR and ESL a little bit, which makes the caps perform better. And yeah, so that's basically it. So try to put them on with as little of the legs left as possible. So make them basically like these. The other ones on that card, like this one, is also not that great. Yeah. So that's the thing about my soldering skills. It's not that good. I can tell you how you want to do it, but I can't really. I'm bad enough, so I can't really do it by myself. So yeah, do as I say, not as I do. And yeah, so now let's get to the voltage thing. Why do I have capacitors with different voltages used in these different fields? Well, because the silver ones are for the V-core power plane, so all the silver ones are on the V-core power plane. Same goes for VMEM. These could also be VMEM. On this card they are V-core. And then the black ones are on the 12 volts power plane. And the thing about capacitors, so there's a little bit more theory right here. You wanna have a matching voltage rating for your capacitors, because if you have unnecessary much voltage rating, like if I use 48 volt caps instead of the 16 volt ones, well, they might be a little bit cheaper, but they will have much higher ESR and ESL. So since we want the lowest possible ESR and ESL, we want to go for the lowest possible voltage rating, which is not gonna be 12 volts for the 12 volt power plane, because the voltage is fluctuating a little bit and you want to keep some slack. Because if the capacitor receives too much voltage, it will blow up. It will just blow up, and you don't want that. If it blows up, you could create a short and you could have a really, really bad day. So don't do that. So for the 12 volts power plane, just go for 16 volt capacitors, and then for any VRM output like vCore, vMem, anything down to 2.5 volts should be okay. I'm using 4 volt caps because I couldn't find any 2.4 volts, 2.5 volts caps. What you want to keep in mind though is that you're gonna please use higher voltage if you want to run your memory very, very high. For example, on motherboards. If you have DDR4, which is Samsung B-Die, those things can do 2.2 volts, I think even 2.4 volts sometimes. At that point your cap will get overvolted and also explode. So at that point you want to use like a 4 volt one. Some motherboards even go for 6.3 volt caps. So yeah, around that. But for graphics cards, like a core is never gonna get 2 volts, and memory also rarely gets 2 volts. So 2.5 volts should be okay. And yeah, so use the right voltage rating for them, because well, too much voltage rating you get high ESR, ESL, you don't want that, and too little voltage rating and you will get a fire, which you also don't want. And yeah, and then also where you put them on. So where you want to put those on, is it more visible on here? Yeah, I think this one looks a little bit better. So you can see I have the 16 volt ones right here. These are connected to the 12 volts power plane. So these two, oops, that's wrong. So these two are just connected to, well, another one of these caps. So the legs, these are through-hole capacitors, so they stick out of the back of the PCB, and I just soldered these two onto the legs. And then this one right here, I soldered directly to the connector. I don't really recommend doing that because you can see there's a lot of solder, and it's, yeah, it doesn't look that great, and it's also really not yeah. Yeah, you don't really want to do that. So just put them on places like this. So on yeah, behind some other caps that are already there. The reason why you don't want to put them right here is because after the connector, what you're gonna have on most PCBs is you're gonna have an inductor that the power goes into, and then it goes into the 12 volts power plane with all these capacitors on it. And what the inductor does, well, basically it reduces the load on the VRM and yeah, on the VRM as the power comes in, because, like, again, going back to speaking of it like water, if you're gonna have a lot of power coming into the card and you have something like a wall, so that wall is either gonna be a VRM or it's gonna be one of those inductors. And so the power, or like the water, a big wave is gonna come in and it's gonna splash against the next best thing that's in its way. And if you don't have an inductor, it's gonna splash against the VRM, which increases load, it decreases efficiency, and probably also increases wear, so it's gonna die sooner. We don't want that. So that's why we put in inductors, because inductors basically do the same thing. They stop the current coming in and they smooth it out. And it also reduces voltage ripple, and like basically you want an input filtering inductor. And so putting the cap right here will put it before the inductor, whereas putting it on the other caps will put it behind the inductor. So yeah, put it behind the inductor, that's just the better way to do it. Like, don't do it like this. Yeah. So now going back to where you want to put them. So for the 16 volt ones, you see like this is an inductor, capacitor. There's an inductor. There's a why am I saying inductor? Capacitor. There's another capacitor. I broke the legs from that one off, sadly. So yeah, be careful. Then these right here are also capacitors, but these are already from the VRM. And you can see that by just looking at them from the other side of the PCB, because they're gonna have their capacity and their voltage rating written on them. And as soon as you see lower voltage rated capacitors, you see, oh, okay, that's the output for the VRM. So these 6 small ones, these are for the VCore VRM, and then this one right here is for VMEM, this one also. So this 16 volt one is actually on the input cap from VMEM, whereas these two right here, these are VCore, and then this one is just in front of everything. And yeah, so the 16 volt one's pretty easy. Just look for caps that are already there and put them on there. So now for the silver ones, you see there are no caps on these points. Why are there no caps on these points? Well, you could put them on there, but you would have a greater effect. They would do more if you put them closer to whatever you're trying to power, so to the GPU. The closer a capacitor is to the thing you're trying to power, the less resistance there's gonna be, and therefore the better it's gonna perform, because, well, the power going from the capacitor to the thing you're trying to power has less resistance in its way. So you wanna, if you want your capacitors to have the greatest effect, put them as close to the GPU as you can. And you see there's still a fair amount of free space on the GPU. I could use maybe these 2 multi-layer ceramics, maybe that one as a hookup point. I'm not doing that right now because maybe eventually I want to attach a VCore sense line, and also it would be kind of hard to fit another cap in there, because like it's gonna take about this much space, and at that point it would collide. So I'm just putting on the 4 on the outside of the core, because well, behind the core you have a really big power plane, so a few millimeters to the side don't make that much of a difference. So I have these 4 caps on the GPU. These 4 caps are gonna have the greatest effect of all the capacitors on that card. And then I have 3 more right here. These are also VCore, and these are on empty solder pads for these right here. So there are these capacitors. These are SMD aluminum polymers, maybe even tantalums. I think that plus right there indicates it's a tantalum. I'm not sure though. So yeah, so these 2 places where I put them on, there were empty solder pads for those, because like NVIDIA just left those out for some reason. And I used those solder pads to attach more of my capacitors. So these are further away from the core than the first 4, but it's still pretty close. Like, they are about halfway there, and I'm gonna clear all that stuff that I put on here. So from a distance, like, you have your normal bulk capacitance right here, and on most NVIDIA cards, at least on older ones, the VCore power plane kind of looks like this. So you have your VRM output here, and then it goes down like this, so the power comes in like so. Because right here you have your memory chips, and therefore there's no place for a power plane right here, because well, there is already a power plane for the memory chips, which basically looks like this. So your power comes in through there, and you see that capacitor is basically halfway there already to the core. It's actually how I made that. It's not really accurate. The power plane goes a little bit more like this. So yeah, these are still pretty close to the core, which means they're still gonna have a decent effect on the performance of the card. So yeah, putting them on there is still definitely worth it. And if at some point like you still feel like you can get the card to run even faster, or like you haven't hit the target that you really want to get, you haven't hit it yet, you can still put caps on here. Like you can see on my GTX 670, you can see right here, those two are also on the output of the VRM. You can see the now those are actually empty solder pads. Yeah, the legs are kind of covered in all this flux residue right here because I kind of messed up on that card. So I have 2 capacitors on the output filtering. Before I actually had 5, but then this happened and I didn't put them back on. So yeah, you can do that. I actually don't know how much difference it did make because I also have these on here on the VCore power plane. The other 4, like these right here, these are on the vmem power plane, so these do nothing for core. Those ones are on the core though. I put them all on at once, so I can't tell you how much of a difference it makes. It will do a little, like a small difference, but I can't tell you if the difference will be large enough for you to get an extra boost step for the core. So, and that's pretty much how you want to put them on. One more thing is I haven't gone over multi-layer ceramic capacitors, so these tiny things right here, just because I haven't bothered with them yet. They are very tiny. The good thing about them, they're not polarized, and polarization, yeah, I'm gonna explain that shortly after, because that's also important. So yeah, these small SMD aluminum polymers, you can also put them on. I actually heard that they do a lot, and because they're so tiny, you can fit a lot of them behind the core. It's just they're very, very hard to attach, they're very easy to break and also easy to lose. And so I haven't bothered with them yet because my soldering skills are still not that great. Then I also spoke about these. These are basically, unless they're tantalum capacitors, these might be tantalums, but you can also get these right here. So you can get this, basically this capacitor in this package, if it's not a tantalum. Because the silver ones I put on are aluminum polymers. Let's just pretend this black one here is also aluminum polymer. You can get the exact same capacitors also in that package, and that package will actually perform better because just the way it's made, you can see that there's not a long leg to attach to the PCB, so your ESL is gonna be much lower, probably also a little bit less ESR. So these capacitors will also perform better. I still haven't used them yet because they're generally more expensive and also harder to attach because like you only have a tiny contact pad that you're gonna have to heat up a lot. And yeah, my soldering skills are not good enough for that yet. So, now coming to polarization. If I zoom in on that capacitor right here, you're gonna see it has this blue mark on one side. And that indicates the ground side, because aluminum polymer capacitors, or basically any capacitor that is not one of these are polarized, which means the capacitor wants to be hooked up in one specific way. So the capacitor has a ground side and a not ground side, which is gonna be either your VCore, vmem, or your 12 volts power plane. And so the markings are there to tell you which side you're gonna have to hook up to ground. And I really don't know, do I have a picture where you can see it? You can see it on the Nichicon ones, those have it in red. So that red marking indicates that this leg, so the side where the red marking is on, is ground. The other side, where there's no marking, is therefore the positive side. So you want to hook that up to your VCore vmem 12 volts. So you can see it here again, blue marking. The black ones have a yellow marking right here. So that leg is ground, that leg is, so that's positive, that's ground, or ground. And yeah, so electrolytic caps, or basically anything that's not a multi-layer ceramic capacitor, they want to be hooked up in this one specific way. If you do not do this, they will blow up. Again, they will just blow up, and that's a bad day. So yeah, always check with your multimeter before you put them on which side is ground, and also after putting it on which side is ground. And yeah, so then you're not gonna do anything wrong. I always manage to put them on the right side. I think at some point I'm gonna mess it up, but yeah, if you react fast enough, you're just gonna lose one capacitor and probably nothing else. So yeah, hook them up in the right direction. So yeah, keep in mind they're polarized. Except you have multi-layer ceramics, like you can put these on in any way you like. Just don't bridge anything or short. And then these right here, these are also, like, I mean, I just said these are the exact same caps. On this one, this is reversed actually. So you can see that there's a plus, which means that, well, the side where the plus is on is your positive side, and the one where there's no marking is, is your negative or your ground. I don't know why it's the other way around. It's just for the SMD package, you have a marking on the positive side, not the ground side. But on the CAN type capacitors, you have the marking on the ground side. So keep that in mind. And I mean, you can always cross-reference with capacitors that are always, like, if you can't remember it correctly, you can always cross-reference it from capacitors that are already on the board. So just take out your multimeter and measure which side is ground and which side is not ground, and that way you can just, yeah, that way you can find out. So yeah, that's pretty much everything I wanted to go over. So yeah, so I think if you couldn't follow all the way, I'm gonna try to do a short recap. So why do we want to put extra capacitors on our hardware? Well, because it is a power reservoir, and if, say, your GPU, your CPU, whatever component you're trying to power needs a lot of power suddenly, it can empty that reservoir first before it puts a load on the VRM, on the power supply, which will slightly reduce the voltage and might end up giving you a voltage drop large enough so that your overclock crashes. And yeah, so, and then what capacitors you want to use? Well, keep in mind that you want the correct voltage rating. Too much voltage rating, the ESR and ESL spec are gonna be trash. Too little voltage rating, the capacitor is gonna explode. So yeah, for 12 volt power plane, just use 16 volt capacitors. For the VRM output, anything from 2.5 volts to 6.3 volts is okay. Just stay away from the 2.5 volt ones if you wanna power something that approaches 2 volts. So like 1.8 volt is okay, but like 1.95 volts is kind of pushing it. At that point, I wouldn't use a 2.5 volt cap anymore. It's probably gonna be fine, but I just like the added security. So at that point, I would just use 4 volt caps. And yeah, so, and then if you wanna put them on, you wanna put them as close to the thing you're trying to power as possible. You can still put it on the bulk capacitors from your VRM. They will help, just not as much as the capacitors you put onto your GPU. And yeah, so the last thing, well, I went over the different kinds of capacitors. It's kind of too long to recap right now. So just keep in mind the polarization. If you start with Capmodding, you're probably gonna start with aluminum polymers. So these are polarized. Keep in mind to not put the ground side to VCore or something else that's not ground. So, because they will also blow up. And then that's pretty much it. This video is shorter than I expected, actually. Just 35 minutes. So yeah, I hope I haven't missed anything. So yeah, that's how a very basic description of how Capmods work. And yeah, how to do them. Capmods are actually pretty easy. The hardest part is actually finding and ordering the capacitors you want. Putting them on is basically just, do you know how a soldering iron works? If yes, just put the ground side on ground. Put the positive side on your positive side, like VCore, VMEM, or the 12 volt side. And yeah, if you don't break anything, like if you don't create any shorts or accidentally desolder something while you're putting them on, there's basically no risk of something breaking. And like, yeah, I mean, still do anything I tell you here on your own risk, but Capmods are actually pretty easy compared to volt mods, which I'm gonna cover in sometime soon, I guess. So yeah, Capmods pretty easy. Basically, like, yeah, it's basically the same thing as the VCore Sense mod that I showed off a while ago. It's just you're gonna have to buy capacitors somewhere. The rest is the same, plus the added where you wanna put them and what rating to get. So yeah, before I ramble on too long, I guess that's it for the video. Thank you all for watching, and we're gonna see each other next time. Goodbye.